Welcome to 14.6, using the equation of a linear model. The first thing that we're going to be looking at is to go ahead and make a trend line to represent our data and find the equation for your trend line. We did this yesterday, so we're going to go ahead and get started with it as a refresher. First thing I'm going to do is find two different plots on our point. I'm going to go ahead and make one here because it's towards the middle, and I think I'm going to make one here because it's that should be a fairly straight line through those. So I have a few at the top and a few at the bottom. This bottom point is 0, 8, and this top point is 10, 11. And so the first thing I have to do is my y minus my y. So 11 minus 8 is 3 over my x minus my x. So I'm going to use the same x that I started with on my y. So 10 minus 0 is 10. So as a decimal, that's 0.3. Then I'm going to go ahead and look for my b. The wonderful thing about what I've chosen here is that I already have my b. Remember when we're graphing, the b is where we start, and we start on the 0, the x equals 0 line. So this is just going to be 8. And I know that because my plot point is just 0, 8. So I've gone over 0 and up 8, which means that is my y-intercept. So this is an easy equation. So I have y equals 0.3x plus 8, because I am only filling in for my m and for my b. Now as I'm looking at it, it says, so I've done the first one, found the trend line, and then I found an equation for my trend line. So now I'm going to look and I'm going to see what is C, about how much would you expect the top grossing movie for 2012 to make in the total revenue. Well, as I'm looking at what my numbers are, this is the year since 2000. So if I'm looking at 2002, that's going to be 2 years since 2000. So I want to know what it will be when x is 2. So I'm going to go ahead and rewrite this, and I'm going to fill in 2 for x. So I'm going to have 0.6 plus 8 is going to be my equation. And so I'm going to say that in 2002, I'm going to have about 8.6 in total revenue. And I'm sure that is million or billion. So that's how I'm going to get my answer. So I'm checking to see, does the information that I have here, is it going to be in the x or in the y? And I'm going to tell that based on the graph. Okay, my next equation, or for letter D, it says, what year would you expect the total revenue for the top grossing movie to be? About 9.5. So as I'm looking at that, I want to know when the revenue is going to be 9.5 million. When I'm looking up here, my total revenue is my y-axis. So I'm going to replace the y with a 9.5. So I want to know, when will y equal 9.5? So the first thing I'm going to do is I'm going to subtract 8 from both sides. I'm going to have 1.5 equals 0.3x. And I'm going to divide by 0.3 on both sides to find out what x equals. So x is going to be equal to 5. I'm just going to check that real quick, and I'm going to see on my trend line, if I go up on the x-axis, up 5, am I going to be at about 9.5? Yeah, that makes sense. So I'm going to say my answer is going to be 5. And then it says for question E, how does your answer to part D compare to the data collected for the total revenue? Well, we've already checked that, and it does make sense. So my answer makes sense based on this for my total revenue. So when I looked at it on the graph, it would have been a dot right about in there. So that would make sense. Okay, on this one, I am once again finding my trend line first. Once I have found my trend line, then I'm going to go ahead and start my information. So my trend line, I'm going to start it probably right about in here. It seems to be about in the middle of those 3 points up at the top. And then as we come down, I'm going to use their line right there at this 83. So I have 83, and then I have 59. So that's going to be my line. Oh, there we go. That trend line is close. So I'm going to do y minus y over x minus x again. My y this time, I'm going to start with the 9. 9 minus 3 is going to be 6. And then because I started with the 9, I have to start with the 50. So 50 minus 80 is going to be negative 30, which makes sense because my line is going down, so it makes sense to have a negative m. So my slope is going to be negative 1/5. And negative 1/5 is the same as negative 0.2. So now I'm going to plug it all in. So y equals mx plus b. I'm going to plug in the y as 3, my m at negative 0.2, my x at 80 plus b. So here, 0.2 times 80 is going to be negative 16 plus b equals 3. I'm going to add 16 to both sides. I'm going to get 19 equals b. And I'm going to check real quick and make sure it makes sense. It does, because it would make sense that I would start up above 10. So my final equation is y equals negative 0.2x plus 19. Okay, so now that I have A and B done, I have my trend line done, and I found my equation. Now it says, what suit thickness would you expect a diver to wear if the water were 30 degrees Fahrenheit? As I'm looking over here, the temperature is something that I know, and it is my x. So I'm going to replace y equals 0.2, and that's a negative 0.2. I'm going to replace the x with a 30 because I can tell that the temperature here is the same as what is on the x line. So I know the temperature, I don't know the suit thickness. So that would be the y. So y equals negative 0.2 times 30 plus 19. I'm going to go ahead and solve that through. I'm going to get negative 6 plus 19, and that's going to equal 13. Then when I do that, I'm going to check my graph if I can, and I'm going to see, okay, if I'm at 30, where would I expect that to be? And I'm saying I'm just above the graph at 13, which would make sense for my trend line. So 13 would be our suit thickness in millimeters. I'm pulling the millimeters from this right here. It should be on the graph, but it's not. Okay, moving into the next one, it says scuba divers wear wetsuits to maintain a comfortable body temperature. And here they've given us the equation to use, which is very helpful. So y equals negative 0.1x plus 14.7. And it says that we want to know what the slope of the line represents in this equation. So we want to know, what does this mean if the x is the temperature of the water and the y is the thickness of the wetsuit? So it has a negative slope, which means as the temperature goes down, then the thickness of the wetsuit is going to need to go up. So we would graph this. We would start at 14.7, and we would go ahead and start going down at this amount, which means as the temperature goes down, then we are going to be going up in the thickness of the wetsuit, just like we saw in our last picture. Okay, moving on to our next one. We're going to find our trend line and then find the equation for the trend line again. There are many different options that you can use. I would go ahead and choose the ones that I can. Our line seems to be kind of in the middle here, so I'm going to pick both of these 2 points and see if we can get it to go there. Okay, on this one, we're going to do movie ticket prices. And I've gone ahead and found my 2 points. So I have 10, 8, and I have 3, 6. Those are the 2 points, and you can see it looks fairly close. y minus y over x minus x is going to help me find my slope. So I'm going to start with the y, so 8 minus 6 is 2. And then I'm going to start with the 10 because I started with the 8, so 10 minus 3 is 7. 2/7 is something that is not going to come out even, so I'm just going to round it to my nearest tenth. So I'm going to say it's about 0.3. Really, my answer came out 0.2857, and it went on. So I rounded to the nearest tenth. Then I'm going to go ahead and plug in. And as I'm plugging in, I'm going to plug in for my m, which is 0.3. Second, let's make that a little thicker. And then I'm going to use this 3, 6. So 3 is the x. I don't know the b, but I want it to equal 6. So I have 0.3 times 3, which is going to be 0.9 plus b equals 6. I'm going to subtract out the 0.9, and I'm going to get 5.1 equals b. When I look at that, it should be about in there. That does look right. So y equals my m times the x plus my b. That's my equation. And then it says, how much will a ticket cost in 2020? So I'm on C now. So the year since 2000, 2020 is going to be 20 years since 2000. So, and this is the x-axis. So I'm going to replace y equals mx. I'm going to replace the x with a 20 because I want it 20 years. And the years is on the x column or the x row. Plus 5.1. And then I'm going to go ahead and work that through. Okay, so this looks like in about 2020, it's going to cost us about $11.10 to go to the movies. Then it says, when did the average ticket cost $6.50? Well, when we're looking up here, we can tell when that is going to be. So the ticket price was about that, about 6 years after 2000. But in order to make sure we have it exactly right, we're going to go ahead and plug it in. So we're going to plug it into this equation, and we know that the y is what we're looking for because that is the ticket price. So I'm going to plug in 6.50 equals 0.3x plus 5.1. I'm going to get rid of the 5.1, or $5.10. So I'm going to have $1.40 left equals 0.3x. I'm going to divide by 0.3 on both sides. So I'm going to say that x would have been about 4.6, which seems a smidge low, but we also know that it's right in there. Okay, here's our last example. Okay, for the sake of time, I'm going to go ahead and I've shown you all of my work to get my equation. And then it says, how many grams of sugar would you expect in a serving of fruit that has 150 calories? So calories is an x, so we would plug that in for the x. So we would have y equals 0.25 times 150 minus 5. And we would solve that one through. So you can go ahead and do that. And then the next one says, how many calories would you expect in a serving of fruit that contains 20 grams of sugar? And the 20 grams of sugar is going to be on the y side. So we're going to plug it into the y. I'm going to do both of those. You can pause it and then you can go ahead and check your work when you're done. Okay, here are your answers. You may go ahead, make sure you have everything written down, and then you can get started on your homework. Good job.